Okay, so let me talk about here partial fraction decomposition. What I want to do is I want to take a rational expression, such as this one right here, writing a rational expression, and split that up into two or more expressions, writing a rational expression as two or more expressions. Because basically what I want to do is break up one rational expression into two or more. And so this one, just to give you what this one does break into, so it's 2 over x minus 3 plus negative 1 over x plus 2. So I take this 1 and make it 2. The reason this is called partial fraction decomposition, these right here, these are the partial fractions. So this is a partial fraction of this one. This is one fraction, these are the partial fractions. Hence the name, okay? We've decomposed it into from 1 into 2. Okay? Now, anybody hazard a guess where those are from? Where did those come from? The x minus 3 denominator and x plus 2 denominator. Well, take a look at this. How does that factor? It's x minus 3, x plus 2. Yeah, so your fractions, denominators of the partial fractions, they come from the denominator factors that you start with. Okay? So that's the first thing to note. Now, the trick is, well, how do you figure out why is it 2 and why is it negative 1? Well, that's what we're going to talk about. So it's kind of an interesting way, because we haven't done any, but probably previously, you took these two and made it 1. Well, we're going to go the other way. That's what we're doing here. Okay. All right, so let's start with this one. 10x plus 8 over x squared plus 3x minus 10. I want to write that, find the partial fraction decomposition for that. All right, so as you probably guessed from what we just talked about, the first step here is to factor, if you can, if it's not already, factor the denominator. And so x squared plus 3x minus 10, factor that out, see what you get. X plus 5, x minus 2. X plus 5 times x minus 2. So that's step 1. Step 2 then is, okay, so what I know by what we just talked about, what I know about that is one of the partial fractions has got to have a denominator of x plus 5. The other one, denominator, is x minus 2. So make, on the other side, two fractions with those denominators. Now, like I said, I gave you the answer on the first one here. I don't know what the numbers on top are, but they are numbers. So let's just call them A and B. And they probably aren't the same numbers, so one's A, one's B. Okay? So that gets us started. Now, to figure this, the A and the B out, that's going to be our answer. I've just got to figure out what A and B are. All right. So to figure out what A and B are, the next step is I'm going to take and multiply both sides by x plus 5, x minus 2. So I'll write it as a separate step here. I may forego that next time, but I'm going to take each part of this basically I'm going to multiply both sides by the x plus 5, x minus 2. So I'm going to multiply, give yourself a little space here in front of these. I'm going to multiply both sides by x plus 5, x minus 2. Multiply the left side, multiply the right side. Now when I multiply the right side by x plus 5, x minus 2, it gets multiplied by both of those. X plus 5 times x minus 2 times that one, and then x plus 5 times x minus 2 times this one. So I've done something legal there, mathematically speaking, to both sides. I just multiply both sides by x plus 5, x minus 2. Now, what happens on the left side? Really nice things happen on the left side. The x plus 5 and x minus 2 all cancel out. So left side now is just 10x plus 8. The right side, not quite as nice, but still nice. When I multiply this one by the a over x plus 5 times that, the x plus 5s cancel out, so let's just write that as a times x minus 2. You can write it the other way if you want, but I'm going to write it as a times x minus 2, and then the other one is, well, the x minus 2's cancel there, and so that's b times x plus 5. Okay? So far, so good. All right, so my goal is to figure out what a and b are. Well, here's the way I can figure out what a is. Notice, if I choose, so x can be anything, right? X is a variable, so x can be anything. If I choose x to be negative 5, what's going to happen here? That's going to be 0. B times 0, that's 0. So I'm going to choose to plug in here x equals negative 5. Throughout this whole deal. X equals negative 5 here, negative 5 here, and negative 5 here. So that's going to be 10 times negative 5 plus 8. That's going to be a times negative 5 minus 2. And I'll write it all out here. We can certainly shortcut this a little bit next time. What does that give me now? Well, negative 50 plus 8 here. A times negative 7 here. And then the reason we chose negative 5 is that gives me 0. And b times 0 is 0. So, yeah, what I wind up with is just an equation I can solve for a. Negative 42 equals negative 7a. Hey, I know what a is. So a is 6. Right? So I've got half the battle here. Half of that figured out. Well, I need to figure out what b is, so let's do the same thing, but let's figure out what a is by choosing a different x to substitute. Figure out what b is. We've got a. To figure out what b is, choose a different x to sub in. What would be a good value to sub in to figure out what b is? Well, x is 2. If I choose x is 2, the a is going to go away. I can figure out what b is. Make sense? So I'm going to go back. I'm going to sub in, like I subbed in x equals negative 5 there. I'm going to sub in x equals 2. Now I'm going to go back to the top there, or to that step anyway. Sub in x to be 2. So that would give me what? 20 plus 8? So it would be 20 plus 8, and then a times 0, and then b times 2 plus 5 is 7. So we got 28 equals 7b. So b is 7, times b is 4. So the answer is, partial fraction decomposition is this with a and b substituted in. So a is 6. So it'd be 6 over x plus 5 plus b over x minus 2. So it'd be 4 over x minus 2. That's our answer. Yes? Is everybody good? All right. So hopefully it'll go, well, there are a couple of little quirks that we need to talk about. But is that okay? Any thoughts or concerns there? So I've got to erase that. All right. So here's the next part to this. All right, so what if we need to do minus x plus 1 over x plus 3 squared? We want to do the partial fraction decomposition, PFD, for short. Well, it's already factored for us, but the kicker on this one is one of the factors is repeated, or the factor is repeated. It's called a repeated linear factor. Here's what you have to do for that. If you have a repeated linear factor, you can't just get by with one thing, one denominator. It actually, so this one, so it's not x plus 3, x plus 3, because that's my factors, right? It's x plus 3 times x plus 3. No, that's not what goes over there. Here's what goes over there. If you have a repeated linear factor, in other words, a factor squared, linear, what you have to do over there is, one of them is x plus 3, but the other one is x plus 3 squared. See the difference there? So if you have a repeated linear factor, yeah, that's going to give me 2, but it's going to be, one of them is x plus 3, the other one is x plus 3 squared. Okay? Instead of x plus 3, that would give me no good. It's got to be x plus 3, and then the other one is the x plus 3 squared. If you have a repeated linear factor. We'll do another one on it. But this one, that's the 2. A, B, top numbers. All right, so what, after we got that figured out, what was the next step? Basically, you clear out the denominators by multiplying by the denominator over here. So, you know, I'll write it out. Okay. So multiply everything by x plus 3 squared. And the good news is, it's going to really cancel out nicely on a couple of them. First and last one, yeah. The x plus 3 squared cancels there, so that's just x minus x plus 1 over here. Well, so a over x plus 3, yeah, an x plus 3 cancels, but that's still going to leave me an x plus 3 to the first there. And then over here, he said that really goes nicely. This is going to be b. All right, so let me put it over here. So we've got minus x plus 1 equals a times x plus 3. And then b. So that was our second step. Third step, we just start substituting x values. What x value would be a good one to substitute for in this case? -3. What you want to do is you want to make this be 0. No. So choose an x value that makes that 0. X equals -3. So it'll be -3, so it'll be positive 3 plus 1. A times -3 plus 3, so that's going to be 0. And then B, there's no substitute, so right off the bat there, since that's 0, that's 0, A times 0 is 0, so you got 4 equals B. Now that will be. Now this one's a little different because there's maybe not a choice that's obvious for the next one. So I've got B figured out, I need to do it again to figure out the A. Is there an obvious choice for what to do that? The X value that would do that? I don't think so. Not an obvious choice, because there's nothing that's going to get the B to go away, since it's by itself, for one thing. That doesn't always happen, but it did happen. So what do we do then? Really, it's the choice is whatever you want it to be, okay? X can be anything. Now, what would be a good choice, you think? 0? X is 0? Yeah. If you can choose anything, why not X is 0? So let's sub in X is 0. And again, we're going back to the original. So it'll be 0 plus 1 equals A times 0 plus 3 plus B. Now, unfortunately, that didn't get rid of the A, did it? So we've got 1 equals 3, or didn't get rid of the B. Didn't get rid of the B, actually. Didn't get rid of the B. But, don't I already know what B is? I know what B is. Since I already figured out B, I know what B is. B is 4. Plug that in. Okay. Yeah. If you know what one of the A, B, or C's, if we happen to have C, if you know what those are, you can go ahead and plug those in. So we got B is 4, so yeah, so now I can figure out what A is. Just subtract the 4. Negative 3 equals 3A, so A is negative 1. So here's the answer. The answer is plug in the A to be negative 1, the B to be 4, back in the original breakdown. So it's negative 1 over X plus 3 plus 4 is B, so it'd be 4 over X plus 3 squared. Okay? Any questions about that? All right. So let's do negative 3x squared minus 7x plus 3 over x cubed minus x squared. Partial fraction decomposition. All right. So the first step here on this one is I've got to factor, don't I? If your denominator isn't factored, you got to factor. So it does factor. I can pull out an x squared. Pull out the x squared, so that'll be an x minus 1 in the parentheses. Yes? Now what you have to note here, what about this one? It's a repeated factor, isn't it? It's got a squared on it, in other words. So what does that mean over here? I got to do 2. I got to do a over x, and I got to do a b over x squared. That's what you have to do if you have a repeated factor, a squared factor. Then I've got to go a third one, so I've got to have a c on this one. So this one's, yeah, so this one's got 3 parts. It said 2 or more, so sometimes you'll have more than 2. Is everybody good? All right, so let's multiply everything by x squared times x minus 1. I'll write it all out. So multiply by x squared times x minus 1, all the way across. A over x times x squared times x minus 1, b over x squared. That's times x squared, x minus 1. And c is over x minus 1, x squared, x minus 1. Cancel out stuff. so all that cancels out, so I have minus 3x squared minus 7x plus 3. Here just the x cancels, so that leaves me an x minus 1, so that'll be a times x minus 1. And then x squareds cancel, so I have b times x minus 1. And over here the x minus 1's cancel, so I have c over x squared. Okay. So that's a little bit longer. Minus 3x squared plus 7x plus 3 equals ax times x minus 1, b times x minus 1, and c is times x squared. And so, obvious choice here is x is 0, right? If I do an x is 0, that's going to make, well, 2 there cancel out, so, and a lot of others. So, if x is 0, that makes that 0, that's 0, that's 3. That's going to be a times 0 times negative 1. That's going to be b times negative 1 and c times 0. So, yeah, these a and c and a couple of terms up here, those all go away because x is 0. All that's left is 3 on the left, negative b on the right. So I got b is a negative 3. All right. Now what? What will be a good choice for the next one? X. Well, I've got x minus 1 factor, so x equals 1. Make that one go away. Yeah, x equals 1. So if x equals 1, that's going to be negative 3 minus 7 plus 3 on the left. X equals 1, so that's going to be a times 1 times 1 minus 1 is 0. B is going to be times 0, and c is times 1. So again, nice things happen. X is 1. This side's negative 7, that's 0, that's 0. Everything goes out except c. C is negative 7. 2 down. So I've got b and I've got c. So I'm going to have to, if I've got 3, yeah, I'm going to have to do this 3 times. And again, this choice for x is not an obvious choice, is there? I don't think there's an obvious choice. Nothing's going to make any of the x's, the terms, drop out. But x can be anything. I've already done 0 and 1. Those will be my first 2 choices if I was just choosing anything. So what do you want to do? You tell me. I don't care. Unless you tell me. 2, okay. That's what I was thinking. X is 2. All right, so it'll be negative 3 times 4, 2 squared, minus 14 plus 3, and then a times 2 times 1. That was a pretty good choice. And then b times 1, and then c times 4. Let's see, negative 12, so is that negative 23? I think it's negative 20. Does that sound right? Anybody believe that? Negative 23 on the left? I think so. Negative 12 minus 14 plus 3. I believe that's negative 23. And then this side we got 2a plus b plus 4c. Uh-oh. Trying to figure out a. Well, like I said, we've already got b and c, so plug those in. So we've got negative 23 equals 2a, and then that's minus 3, and then 4 times c, so that'd be 4w minus 28. All right? So I've got negative 23 equals 2a minus 31 plus the 31. So we got negative 8 equals 2a, so a is negative 4. So my answer, well, it goes in. What's the answer here? So here's my answer, just with A, B, and C plugged in. So it'd be negative 4 over x plus b over x squared. B is negative 3, so it'd be negative 3 over x squared. Plus c over x minus 1. C is negative 7. They're all negative. Okay. Didn't think that's what the answer was, but I guess so. Is that right?
Wouldn't 8 be positive down there? 31.
Oh, positive. Ah, okay. That's what it was. Thank you. Just checking. Positive 4. Thank you. I was thinking I didn't design one with all negatives, but. Okay. Just enough time, I think, hopefully anyway, for one more. One more little quirk. All right, so 5x plus 10 over x minus 1 times x squared plus 4. Now, the good news on that one is we've already got it factored out. Because the reason I'm bringing this one up, can I factor that? If it was x squared minus 4, I could. X squared plus 4 is sum of squares. You can't reduce that. So this is an irreducible quadratic factor. Throw the term at you here. I got an irreducible quadratic factor right there. Here's what you have to do for that. All right, so nicely though, to start with, the two denominators are just like they are. They're already factored out for me, so those are my two denominators. I'll put parentheses. So that's good. I don't have to do anything special as far as the denominators go. So this is A. But here's the thing. Since that's quadratic over here, you can't get by with just a number on top. Since that's quadratic, what you have to do is you have to do a linear factor on the top, so it has to be bx plus c. See that? If you've got a quadratic factor here, irreducible quadratic factor, the top has to have an x in it. So it's bx plus c instead of just a number. Okay? That's how it plays out. Okay? Other than that, it's the same. All right? So let's multiply everything by x minus 1, x squared plus 4. I don't know. Save some writing here. Let me just do it this way. So do that times all of those. So it's going to be 5x plus 10 here. The x minus 1s will cancel, so it'll be a times x squared plus 4. And then here, the x squared plus 4s will cancel, so it'll be bx plus c times x minus 1. All right. So the choice here will be x equals 1. For obvious choice there. X equals 1. That'll get rid of that. That'll be 0 for that one. So it'll give me 5 plus 10 on this one, 15. A times 5 for that. And then x is 1, so that'll be b plus c here, but it's times 0. So that term goes away, so I just have 15 equals 5a. A is 5. A is 3. Okay? Well, it'll be another obvious choice. Hopefully obvious. Well, since b is times x, B is, if I do x is 0, that's going to be another excellent choice here. So plug in x to be 0 here. So that would be 0 plus 10 equals a times 0 plus 4, so that would be 4. And then plus b times 0, so that would just be c here, parentheses, and 0 minus 1 would be negative 1. So I have 10 equals 4a minus c, but the good news is I know a is 3. So that's 10 equals 12 plus 12 minus c, so subtract 12. C is going to be negative 2 is negative c, so 2 is c. But as far as obvious choices go, so we've done 1 and 0 again. 2 again? Let's do 2 again. So plug in x to be 2 here, so that'd be 10 plus 10. And then a times, what's x to 2, so it'd be 4 plus 4, it'd be 8. B times 2, so 2b plus c times x is 2, so that'd be times 1. So I've got 20 equals 8a plus 2b plus c. Good news is I know a and I know c, so a is, what was a, 3, c is 2. We got 20 equals 24 plus 2b plus 2, so I've got b figured out here. Right? That's 26, so that's 2 to 6 equals 2b, so yeah, b is negative 3. So the answer on this one is, right up here again, what's the answer here? So I've got a over x minus 1, so that would be 3 over x minus 1. And then bx plus c, so b is negative 3 plus 2, c is 2, so that would be the other part to it. All right, I don't have time to go through this whole one here, but let me just get it set up for you. One more kind of like that. This one is, it's long, x cubed minus, no, x cubed plus x squared plus x minus 1. Sorry. X squared minus x plus 7. That's over x to the 4th minus 1. So let me just get this one set up and hopefully take it from there. But so this one is, yeah, I've got to factor the denominator here. The thing of the denominator is, well, x to the 4th minus 1, well, it's a difference of squares, which is x squared minus 1, x squared plus 1. One of those factors, one of them doesn't. The first one factors, the second one doesn't. So this one factors as x minus 1, x plus 1. This one doesn't factor. All right, so that's my denominator. Factored. X plus 1, x minus 1, or vice versa, times x squared plus 1. That x squared plus 1 doesn't factor. So what are my fractions over here? Well, I need one of each of those. Of course, that's a and that's b. Those are just numbers, but what about that one? That's the quadratic, irreducible, quadratic. So what do I need on top of that? Cx plus d, yeah. If it's irreducible quadratic, you need an x term to go along with the number on top. Then you go from there. Okay. So you'd have 4 to figure out. On that one, you're gonna have to do 4.